Hi everybody, Mrs. Dunn again. This is part 2. In part 2, we're going to do all of the same things, finding the vertex, the axis of symmetry, the x-intercept, y-intercept, max, min of a quadratic function. But we're going to do that when the function is in standard form. So if you remember, we talked about vertex form in the last section. Now we're going to talk about standard form. So here's an example of a quadratic function that is written in standard form. So f of x is equal to 2x squared minus 4x minus 7. And just like before, we're going to go through and we're going to find the vertex, the max, the min, where it is, the axis of symmetry, the y-intercept, the range, and the graph. There's some of these questions, a few questions, I'm going to point them out to you right here, that you can answer right away from this graph. Since 2 is positive, we know that this u is going to be facing up. So we say that this has a minimum value. Another question I can answer is the y-intercept, because the y-intercept is when you plug a 0 in for x. So I know the y-intercept is -7. Okay, so I already know 2 of those answers. But let's go through and let's talk about the rest of this. So I don't know the vertex. So there are 2 ways to find the vertex. And one of them is to put it into vertex form. So you could take this equation that's in standard form and you can put it into vertex form. Putting it into vertex form requires you to complete the square. I know completing the square is everybody's favorite thing to do. All right, let's get started. So, the first thing we need to do is factor out a 2 from those 2 terms that have the x's in them. So remember, I'm factoring out a 2 because I can't complete the square unless the lead coefficient is 1. So that gives me x squared minus 2x. This minus 7 is on the outside. So remember, in the next step, I got to figure out what to add here, and I'm going to be subtracting it on the right-hand side here. It's on the same side of the equation, though, because whatever I do inside, I'm going to do the opposite outside. So what I add inside the parenthesis is half of 2. Half of 2 is 1, and then square that number, and 1 squared is 1. So I'm adding 1 inside, but I'm really adding 2. 2 times 1 is 2. So I'm going to subtract 2 on the outside of the parenthesis. So I end up with 2 times x minus 1 squared minus 9. Since it's in vertex form, so we had standard form, this same equation written in vertex form looks like this. So we can find that vertex very, very easily. Do you remember what the vertex is? Hopefully you know that the vertex is 1, -9. Is that vertex a max or a min, and where does that occur? Well, since 2 is positive, it's definitely a minimum. And so the minimum is -9, and it occurs at 1. What about that axis of symmetry? The axis of symmetry is the vertical line through the vertex, so it's x equals 1. The y-intercept. The y-intercept, remember, comes from plugging a 0 into the original function. So if we plug 0 into f, so everywhere I see an x, I'm going to plug 0. Remember, like I said earlier, you're going to get -7. So the y-intercept is -7. And then I also want to know the range of this function. Well, since I know this is a minimum, so the bottom of my graph is going to be -9. That's the smallest y value it goes through. And the biggest y value it goes through is infinity. And then lastly, let's look at the graph. And you can plug it in your calculator to look at it. You can plug either one of these equations. You're going to get the same answer. But this is what the graph should look like. Okay? All right, the next thing I want to do is talk about another way to find the vertex. So I wrote a better way. I don't know. Some people don't like completing the square. Sometimes those fractions get icky. And if the fractions are really not your best friend and you don't like dealing with fractions, this might be a better way for you. So you don't have to complete the square with fractions. So the x part of the vertex, there's a formula for that. So that x part of the vertex, which is called h, is always equal to negative b over 2a. So remember, here's b and here's a. So negative b over 2a for this function is the opposite of negative 4 over 2 times 2. 4 divided by 4, which is 1. Remember, that's what we got before. Now, how do we find the y part of the vertex? Well, you plug 1 back into the function. So find f of h, or find f of 1. Plug 1 into that equation. And when you plug in 1, you get negative 9. So that's another way to find the vertex. Be sure to watch my screencast where I go through some applications of the quadratic function. It's going to be a lot of fun. See you next time.